Shalom and welcome everyone. Once again, I want to thank you for joining me in Checkpoint Training Bytes. Checkpoint Training Bytes is where we bring you advanced training on different Checkpoint products, features, and blades. In this module, we'll be looking at ClusterXL and ClusterXL technologies. Again, my name is Manuel Joe King, and I will be your instructor. So please sit back, relax, and let's get started. So first of all, let's take a look at the agenda of this module. The first topic we're going to discuss is what is clustering and what is ClusterXL. Then we'll take a look at ClusterXL methods and discuss the different modes that these methods contain. Then we'll also take a look at the ClusterXL synchronization and how synchronization works with ClusterXL. Fourth, we also will look at the clustering control protocol, what this protocol does and what its purpose. And finally, we'll look at some P-notes and clustering statuses. So let's first discuss why you would need clustering. Now imagine you're sitting on your PC and you're trying to get to the internet, so traffic is being forwarded to the firewall and from the firewall out to the internet to some server out there that you're accessing and viewing information. Now imagine if the firewall crashed while you're trying to view the information, then you would not be able to get any data from that web server. And so clustering is a solution that offers redundancy. Redundancy means that you have more than one system in case one of the systems fails. If the system fails, all traffic will be directed to a redundant firewall or a backup firewall, and the traffic will go to the internet and then back to you. One other condition of cluster is that the failover should be transparent, meaning that the user will not know that there's actually failure on the firewall. And so if a firewall fails, from the user's perspective, he will not see any performance degradation on his network because the traffic will be forwarded to the actual firewall that's still active. And so it's transparent from the user perspective, and it's also transparent from administrator perspective. The administrator did not need to change any routes to forward the traffic to the secondary firewall. It automatically was forwarded to the secondary firewall and out to the internet. Also, clustering can also refer to a fault tolerance. Fault tolerance in essence means that you can have more than one system, and so obviously you can have more than one user, and so half of the traffic will be sent through one firewall, the other half of the traffic will be sent through the other firewall. If one of the firewall fails, then the traffic that was sent through that firewall will be redirected to the firewall that's still up. And so fault tolerant in essence means that whatever traffic was being processed by one of the systems is now going to be processed by the other system. And so to recap, a cluster should first of all be redundant, meaning that you have more than one system for backup purposes. And two, it should be transparent from the user's perspective and also from the administrator's perspective. And three, the cluster should also support fault tolerance, and so the load that was being processed by the firewall that went down has to be distributed to the firewall that's still active. And so now that we discussed what a cluster is, let's discuss what a cluster is not. A cluster is not where we have a redundant pair of firewalls. Let's say both firewalls have the same IP address. One of the firewalls is actually turned on, the other firewall is turned off. They're both stacked in the same rack in a server room, and obviously all traffic is going to be forwarded to the machine that is on. And in case that machine actually goes down, administrator has to go into the server room and power on the machine that's off, and now all the traffic was going to be forwarded to this new machine. And so this is not a cluster because it was not transparent, meaning that the administrator had to go in the server room and power it on. Also, from the user's perspective, they had some downtime while they waited for the administrator to power it on. And it's also not fault tolerance because there is no traffic and load distribution. But yes, it is redundancy because you have multiple systems, but this is not a cluster. So now let's take a look at another solution that is also not clustering. Assume that we have two firewalls. Both firewalls are actually powered on. They're running. And each firewall has their own IP address. This is .1, this one is .2. From the gateway's perspective on the user's PCs, the gateways are all pointing to dot one, and so this machine is pointing dot one. This one is also pointing dot one. So all traffic is being forwarded to the firewall dot one. In case the firewall dot one goes down, the users, they have to go to the default gateway and change the default gateway to dot two, so that all traffic will now be forwarded and redirected to the gateway dot two. Now this is redundant because you have multiple systems, but it's not transparent from the user's perspective because the users had to change the default gateway. I've seen a similar solution. Instead of defining it at the gateway level, they place routers upstream closest to the firewall, and the router themselves have the default gateway, let's say pointing to dot one. And so now if dot one crashes and goes down, the administrator, he has to connect to the router and change the default gateway to dot two, so all traffic will be forwarded to dot two. And so both of these solutions are feasible in the sense that you have redundancy built in, you have multiple gateways backing up each other, but you have limited transparency because either the administrators has to define the routes on the routers or the users have to change their routes on their PCs. But a better solution that I've seen administrators do is enable dynamic routing like RIP or OSPF and enable that on the firewalls on the routers. And when the firewalls goes down, dynamic routing will learn about the next best path, and in this case we'll forward the traffic to firewall.2. So this solution is a valid solution in the sense that you have redundancy, you have multiple gateways backing up each other, but there's limited transparency in the sense that if a user is going to the internet while the firewall goes down, he actually can experience a downtime while the routers are learning and propagating these new routes. And so now that we defined what clustering is not, let's define what clustering is. A cluster should be a redundant solution, a cluster should be a transparent solution, and a cluster should be a fault-tolerant solution. Now, you don't have to have all these three ingredients, but the more options you have, the better and more stable your clustering solution is. And so clustering should be a redundant solution where we have multiple gateways, a minimum of 2 gateways, a maximum of about 8 gateways. And it's also a transparent solution where we have a virtual IP address, so all PCs will be pointing to this virtual IP address as their default gateway, so all traffic will be forwarded to this virtual default gateway .3, and this .3 is actually a virtual IP address that's actually owned by all the machines that are part of the cluster, so all traffic will be forwarded to all the machines that are part of the cluster, and one or more machines can process this connection depending on what kind of clustering solution you've enabled. And depending on what clustering solution you've enabled, you can also guarantee fault tolerance if needed. So now let's talk about the different clustering solutions that Check Point offers. The first is ClusterXL. It's a proprietary Check Point clustering solution invented by Check Point and only used on Check Point firewalls. The second is VRRP, and VRRP is an industry standard clustering solution that's used by multiple vendors like Check Point, Nokia, Juniper, Cisco. And so Check Point offers actually both solutions. In this video, I'm only going to talk about ClusterXL. In the next video, I will do a demonstration, a presentation of VRRP. So ClusterXL, there's actually 2 methods of setting up ClusterXL. The first method is called high availability. The second method is called load sharing or load balancing. Sometimes you can use these words interchangeably. So there are 2 methods, high availability and load sharing. Now in these 2 methods, there are 2 modes for high availability. The first mode is called the legacy mode. The legacy high availability mode is actually, like the word says, legacy. It's no longer used, no longer supported. And the second method is called the new HA mode. The new HA mode is actually the one that most people use and currently is supported and used on the Splat and also on Gaia operating system. Legacy HA mode, as mentioned, is no longer supported. In its place, we now support VRRP. Legacy HA was supported on Splat. VRRP is supported on Gaia. In load sharing, load balancing, we also have 2 modes. A simplified version is called unicast method. The unicast method is an easy, quick way of setting up load sharing. A more advanced, powerful method is called multicast. The multicast method is a more efficient, more powerful method of doing load sharing clustering. Okay, so let's take a look at the different clustering solutions. Let's discuss the high availability solution. High availability solution is that you have two or more firewalls in the cluster. One of these firewalls is going to be in active status, and the rest of the firewalls are going to be in the standby status. And so the active machine, he's the one that's actually going to be processing the connections and forwarding the connections out to the internet. In case the active machine ever goes down or has issues or it crashes, the active machine goes down. The standby machines are monitoring the state of the cluster, and so they recognize that the active machine went down, and so they promote themselves from standby mode now into active mode. And so all traffic now will be redirected to this new active machine, which is going to process that connection and forward the connections out to the internet. So next, let's take a look and discuss the other mode of doing clustering, which is load sharing and load balancing. In load balancing, load sharing, all firewalls are in active status. So you have two or more firewalls in active status, and so all traffic is going to be forwarded to the active machines. In this case, all the machines are going to receive the connections, and they're going to run a route algorithm, and one of these machines is actually going to process that connection and forward the connection through. So you have load distribution because you actually have two machines or more machines in the cluster and processing connections at the same time. And so just to summarize, we have two ClusterXL methods, high availability method and the load balancing load sharing method. High availability, there are two modes. The legacy mode, which has been discontinued, the new high availability mode, which is an active standby solution, and the unicast and multicast, which are both active solutions. And we also offer the VRP mode because the legacy HA has been discontinued. Legacy HA was supported in Splat operating system. Splat is being deprecated, and so on Gaia we support VRP, and we also support VRP on IPSO operating system. And in order to make ClusterXL redundant and transparent, ClusterXL works with a virtual IP address. There's a virtual IP address that all traffic will be forwarded to the virtual IP address, and each of the machines has obviously a physical IP address. So when the traffic is forwarded to the virtual IP address, it could be processed by one or more machines depending on the clustering solution that you have. If you're using HA, only one machine is going to be active and the other one is going to be standby, so all traffic will be forwarded to the active machine. If you're using the load sharing, load balancing solution, you're going to have two machines in active status, and so traffic will be forwarded to the virtual IP address, and they could potentially be processed by one or more machines in a unicast multicast method. And so there are some requirements when you're setting up ClusterXL in order for ClusterXL to work properly. The first requirement is that the operating system should be the same in all the machines in the cluster. So if one machine is running, let's say, Gaia operating system, all the machines have to be running the same Gaia version on all the machines in the cluster. The second requirement is the firewall version. If one machine is running, let's say, R77 firewall version, all the machines in the cluster have to be running R77. The third requirement is also the hotfixes. If one machine is running hotfix XXX, all the machines in a cluster have to have hotfix XXX. And the fourth requirement is that the hardware should be the same. Let's say I use the 4000 series appliances, then all machines should be 4000 series appliances. Now Check Point recommends that they be the exact same hardware appliance, but sometimes it's not feasible. So this could be a 4000, let's say 200 system, and another one could be 4000, let's say 400 system. And so even though they're not the exact same hardware, they're in the same series, and so that also would work for clustering. Also, another requirement is that all machines that are part of the cluster have to have the same products and blades configured. And the final requirement is to have the same time configured in all the machines that are part of the cluster. And so it is recommended either to use the same GMT time and time zone on all the machines in the cluster, and it's also best practice to use, let's say, an NTP server and configure all the machines to use an NTP server, and so they'll be polling the NTP server, and so all the machines will be synchronized with each other and have the same time and time zone. So the next thing I want to talk about is the state synchronization. Now to discuss state synchronization, let's go through the whole topology of a network. Let's say you're sitting on a PC and you're trying to access an FTP server out somewhere on the internet. And so the user, he's going to open the connection through the firewall, in the active firewall, in this case firewall 1. The active firewall is going to look inside the rule base to see if there's a rule allowing this user to get out to the internet. And in this case, let's say there is a rule, so it's going to keep track of this information at the kernel. In the kernel, there are state tables keeping track of all the connections that the users are opening. In this case, it opens a connection between host X and server Y. So in the state table, we have a connection X to Y. Alright, so these connections are stored in the state table, and then the connection goes out to the server. Now assume now that this active firewall, it crashes, it goes down. And so if the active firewall goes down, the standby firewall has to promote itself to active status. So the standby becomes the active machine. So now the connections, instead of going through the firewall 1, the connection is now going to go through firewall 2. What would happen if firewall 2 becomes active? That existing connection, that FTP connection, is dropped. And it's dropped because it's packet out of state. The firewall does not know about the state of this connection. And so the packet is dropped as out of state. And so to prevent these packet drops out of state, what we do is we need to sync those connections from the original active machine to the standby machine. So let's take the scenario over again. Let's start over again, where we have a connection from the user trying to access a connection to the FTP server. So the user opens the connection, he goes out and it goes to firewall 1. Firewall 1 looks in the rule base, there is a rule allowing it, updates it in the state tables. Now the state tables need to update the standby. That firewall 1 needs to update firewall 2 about this connection, so that firewall 2 will also have the same state information about connection X to Y. And so when there is a failover from the active machine, the standby machine becomes the active machine, and now the connection is going to be forwarded to this firewall 2, and firewall 2 looks in the state tables and it finds a match in the tables. And if it finds a match, it allows the connection. And so there was a transparent failover because ClusterXL took care of the failover from the active machine to the standby machine. And also from the user's perspective, there was a seamless failover. The user was not affected and interrupted. That session that he had open, the FTP session, is still open even though there was a failure on the network. And so in order to get all the sync connections to be synchronized across all the cluster members, we need a special cable called the sync cable. And the sync cable is either a crossover cable between two firewalls or connected to a switch. And so the sync connection is where all the kernel connection tables will be synced across all the members. And so it could be either a dedicated crossover cable or connected to a switch. And so all connections that are being processed by firewall 1 is going to also be processed by firewall 2, and it's going to be synced over that sync network. And so every connection that comes in to the active machine, let's say this is the active machine, and again this is the standby, and so all connections coming into the active machine, and if it's processed and accepted by the rule base, it's going to update in the kernel tables, and it's going to sync through that sync cable and update that members kernel tables in case there is a failover, that the standby will know about the existing connection. So every connection that comes in will be updated in the kernel tables and sync with the cluster members. So the next thing I want to discuss in relationship to state synchronization is we have two kinds of state synchronization. We have what we call full synchronization, and we also have what we call delta synchronization. Now the difference between them is in full synchronization, let's say I have an existing connection table. And so on my active machine, I have a bunch of active connections, and I need to synchronize those connections to one of my cluster members. Let's say one of my cluster members is powered off, and now I'm powering it on, or maybe one of my cluster members needs to be rebooted, or one of my cluster members is trying to join the cluster. The synchronization needs to happen across the cluster members. And so on the sync network, we're going to have all of our connections A, B, C, D, and E being synced across the cluster members so that all machines in the cluster will have the same amount of connections in the connection table. Now that's what a full sync is. A full sync happens during reboot, or maybe a machine is joining the cluster or powering on the system. Now let's assume now we have all of our connections synced amongst the cluster members, and now a new connection comes in. Let's say this client opens a new connection through the active firewall. The active firewall processes that connection and it updates it in its connection table. So that connection needs to be synced. Do we need to sync the whole connection table? No, we don't need to sync the whole connection table. We only need to sync that individual connection, and so we're going to sync that individual connection. This is what we call the delta sync. The delta sync is individual connections being synced. And again, we have another connection coming in to the active machine. The active machine processes that connection. It syncs it using the delta sync. Now the member knows about that active connection. Now correspondingly, let's say one of the connections is deleted, is removed from the connection table. Now the active machine needs to synchronize that connection and update the member that that connection has been removed. And so the cluster members are constantly updating each other about the connections in the connection table, either using the full sync when the machine has been powered on or rebooted, or using the delta sync when they're synchronizing individual new connections. So the next thing I want to talk about is the clustering control protocol. The CCC protocol, I also call it the Check Point Control Protocol. This protocol runs on all the interfaces, the external interface, the internal interface. And Check Point Control Protocol is going to be sent from all the members to all the members. So the member Firewall 1 will send clustering control protocols to Firewall 2, and Firewall 2 will send clustering control protocols to Firewall 1. On the external, internal interfaces, the DMZ interfaces, all interfaces that you've configured ClusterXL on. The clustering control protocol is going to be updating the status of all the cluster members. What status information? Well, there's a few things that the cluster control protocol will be updating all the members. Number one, the clustering control protocol is going to send health status reports. And so every second, it's going to send 3 packets. The clustering control protocol is like a health keep alive, notifying the members that they're still active, up and running. And not only do they notify the state that they're in, but also the state that they think that the members are in. And so if one of the members fails to send these health status updates, it will notify one of the members that there is an issue. And so the members need to set a course of actions in order to resolve the situation. Number 2, the clustering control protocol is sending state changes updates. And so if you have an active machine and the active machine wants to go into the standby mode, it will send these updates. Or if you have a standby machine and it's trying to become the active, the standby machine will update all the members that it's now coming up as the active machine. Or you might have a cluster that's going down, and so cluster control protocol will notify all the members that it's going down and leaving the cluster. Third, cluster member probing. Cluster member probing is the members will probe to see if the other members are still part of the cluster. For example, let's say one of the firewalls fails to send health status reports, and so the member will not receive any of these packets. And so it sends probing requests to identify and elicit a response to see if that member either is still up or if that interface went down. And so depending on the outcome of the probing, it will then make a determination on what the next course of actions to take. And fourth, querying the cluster membership. So when the machine is first coming online, it's going to query the cluster to identify which machines are actually in the cluster, what state those member machines are in, and to signal that it's trying to join the cluster, and to identify what state it should join in when it joins the cluster. And fifth, the clustering control protocol also runs over the sync network. Now, this is a specific kind of cluster control protocol, and it's only used for syncing the kernel tables. All the firewall members are syncing their kernel tables amongst each other, and so it uses the sync network that runs the cluster control protocol to sync the kernel tables. Now, the next thing I want to talk about is cluster status. Now, I did talk about cluster status a little bit when we talked about high availability, and we also talked about load sharing. I mentioned in high availability you have one machine that's going to be active and all other machines are going to be in standby status. And I also mentioned in load sharing, load balancing, you're going to have all the machines are going to be in active status. Now, I mentioned this, but I really didn't define what these states mean. So active means that everything is okay and this machine is actually running and passing traffic. And so in high availability, the active machine would pass traffic, and in load sharing, it could be one or multiple machines passing traffic. Now in the standby status, this standby only happens in high availability mode,
in high availability, you're going to have one machine inactive. Every other machine is going to be in standby status. And so basically the standby is the machine that's dormant. He's passively listening for traffic, hello packets from the active machine in case the active machine has an issue and he goes down, then the standby will promote himself to active status. Now the other status is the down status. The down status can happen for one of two reasons. Number one is if administrator sees that he needs to do some maintenance work on the system, and so he might bring an active machine or a standby machine into a down state, which will remove him from participating in the cluster, and then he can do some maintenance on the system. The second reason is if the system itself recognizes that there is an issue, either an issue with one of the processes that have a problem, or maybe the policy has an issue, or maybe the sync has an issue, and so the system will recognize that there is a problem and automatically kick himself out of the cluster, and so he will go into a down state, which notifies all the other machines that he's no longer passing the traffic, so the traffic load has to be distributed amongst all the other members. So next, let's talk about active attention state. The active attention state can happen in a specific scenario. Let's say you had two machines in the cluster and one of the machines went down, and you have one last machine passing traffic. Now later on, this machine recognizes that he has an issue with one of the processes or one of the services, and so normally he would go into a down state, but if he would do so in this situation, you would have a network down issue. And so to prevent a full network outage, instead of going into a down state, he goes into active attention state. And this, in essence, notifies the administrator that there is an issue with this cluster, not to rely on this cluster, and so he needs to address whatever issues were on the other systems. And when those systems come up into active state, and the active attention will eventually then go down into a down state, and then the administrator needs to rectify and resolve the issues on that system. Next, let's talk about the ready state. The ready state can happen under three different scenarios. The first scenario, let's say this machine wants to join the cluster. And so before he joins the cluster, he's ready, he's loaded all the software, and he does a query request to all the members, notifying him that he wants to join the cluster. Now, he will only join the cluster when all the members agreed that he can join the cluster and what state he should join in on. And once he joins the cluster, he will go into active or standby state. Now, another scenario can happen if the software versions are different. So let's say the cluster members are running R77, and this new machine who wants to join the cluster is running R76. And so he does a query request to join the cluster, and all the members deny his entry into the cluster because he has a different software version, and so he's kind of stuck in the ready state. The third scenario is if the hardware, in this case the CPUs, are different. And so let's assume this machine has 4 cores, this machine has 2 cores. Again, he goes into the ready state, he does a query request to the members so he can join the cluster. The members deny his entry because they have 2 different amount of cores. And so in order to solve this, you can obviously add more cores, and so they have the same amount of cores, or you could reduce the amount of cores on the members, and so they will have the same amount of cores, and then they'll be able to participate in the cluster. So next, let's talk about the initializing state. The initializing state is not an issue per se. This happens more when the system is been rebooted or a system is being powered on, and while it loads the services and it waits for all the services to load, it goes into initializing state until all the processes and services are fully loaded, and then it will do a query request to join the cluster, and will go into a ready state. And when the members acknowledge that he can join the cluster, he will go into active or standby state depending on what was agreed on. And now the last state I want to talk about is the ClusterXL inactive or machine is down state. And this state can happen in a scenario where machines are participating in the cluster and all the machines and members know about each other. And now one of the machines either crashes or goes down, and so there's no health status reports being sent from that system. And so all the members will send probing requests to identify if that system is still up and active. And since that system is down, there are no response forthcoming. And so from their members' perspective, that system is actually down. And so they're going to mark that system as cluster inactive or machine is in down state. Okay, now that we come to the end of our video, let's take a few moments to discuss and summarize everything that we discussed during this presentation. And so the first thing that we discussed is that ClusterXL is a proprietary checkpoint clustering solution that offers transparency, that offers redundancy, and also offers fault tolerance. So the next thing that we discussed is the different clustering XL methods. In the cluster XL, we have two methods. We have a high availability method, and high availability is where we have one machine inactive and all the rest of the machines are in standby, and so traffic is being forwarded to the active machine, and only the active machine is processing the connections. And in high availability, we also said that we had two methods or two modes of setting up high availability. The first mode is what's called the legacy mode, and the legacy mode is actually being deprecated and no longer used and no longer supported. And we also have a new mode called the new HA mode, and the new HA mode is the current most popular method of setting up high availability. Now we also have a different method called load sharing, load balancing for ClusterXL. In the load balancing, load sharing, we also have two modes. We have a unicast mode and we also have a multicast mode. Now in load sharing, load balancing, all the machines are in active status, so potentially one or more machines could be processing the connection at the same time. And so the next thing that we talked about is the ClusterXL synchronization network. The sync network is actually a cable between the cluster members, either a crossover cable or a cable connecting to the switch. And all the cluster members have kernel tables that are keeping track of the connections that are being processed, and these kernel tables need to be synced amongst the cluster members. And we also talked about the full sync versus the delta sync. And I mentioned that the full sync happens when the system is first rebooted or powered on. It needs to join the cluster, but before it joins the cluster, it needs to request all the kernel tables from one of the members. And so the members will provide all the kernel connections that they knows about to this new member that's joining the cluster. And so in case there is a failover, this machine that's joining the cluster will know about all the existing connections, and so no connections will be dropped. And then we talked about the delta sync, and the difference between the delta sync is the full sync is after the full sync has been accomplished and is completed, now new connections that are being processed by the firewall need to only update these individual connections. And so the delta sync is every new connection that's being processed needs to be synced with all the cluster members. And next, the next thing that we talked about is the clustering control protocol, the CCP protocol, which is the proprietary protocol that's used in the ClusterXL. And checkpoint control protocol is used for many different things. It's used for health status updates. The cluster members are going to notify every machine that's belongs to that cluster about their health and what state they're in. Also, the clustering control protocol is used to probe and identify if members are still in the cluster or if members are inactive or have failed. Clustering control protocol will send probing requests to elicit a response from the failed members. Also, the cluster control protocol is used to update the cluster members about any and every state change. So if there's a machine that's leaving the cluster or a machine that's changing their state either from active to a standby or from a standby to an active state, each and every change needs to be updated to the cluster community. Also, the clustering control protocol is used to query for new cluster membership. And so if a new machine is trying to join the cluster, it needs to query every machine in the cluster to identify what state he should join in as and also when he should join. And also the checkpoint control protocol is used on the synchronization network to sync all the kernel tables amongst the cluster members. And it's a special kind of packet that notifies the cluster members that this payload contains important kernel tables. And the last thing that we talked about is the cluster status. We talked about the active status, which means that everything is okay and the packets are being forwarded, and so there was no issues with the active status. And also we talked about the standby state, and the standby state is only available in high availability, and the machine will be in standby and it's basically dormant. It's listening for the active machine, and in case the active machine goes down, one of the standbys will kick in and go into active status. And then we talked about the down state, and so if there is a problem with some of the services or processes, the system could remove itself from the cluster, and so it can go into a down state. And the down state, it does not process any connections and does not forward any packets. And so there is an issue, and the administrator will need to address and resolve why the system is in the down state. And then we talked about the ready state. Now, the ready state can happen for a few reasons. Number one reason is if a machine is trying to join the cluster, and it will send some query requests to identify when it should join and what state it should join. And while it's waiting, he will be in ready state. Now, a machine can also be stuck in a ready state in certain situations when he tries to join the cluster, and maybe the software is different from the actual cluster members, that the members won't allow him to join the cluster because they will be on different versions. Also, if the hardware is different, like example, if they're using different amount of cores, a machine that's trying to join the cluster might be stuck in a ready state because other members will not allow him to join the cluster. Okay, and the next state is the initializing state. In this state, there is actually no problems, and this happens in the situation when the system is first booting up. And while it boots up and loads the ClusterXL processes and services, it goes into initializing state while the rest of the processes and daemons finish loading. And once they finish loading, then it goes from initializing state and to a ready state, and it probes the cluster members to participate in the cluster. And the last state is the ClusterXL inactive or machine is down state. And this can happen when an actual member goes down, and the rest of the members will try to elicit a response to see if that system is still active. And if it gets no replies, then the members will mark in its table that that member has actually went down. And so you'll see the ClusterXL inactive or machine down when actually a machine is not replying to any probe requests. And so with that being said, that brings us to the end of this video. I hope you found this information informative, and if so, I am working on ClusterXL Part 2, and I hope to see you there. Until then, bye for now. Shalom.
Checkpoint. We secure the future.